Good evening, everybody. Welcoming Andrew Kirton-Vaughan from north of the border. He's very lucky, but a few years ago we let him in. We must have had a brainwave, I think. But we haven't regretted it totally, let's put it that way. So Andrew studied it for his Masters in Materials and Engineering Science at St John's College, Oxford, and a Master of Science in Materials and Manufacturing Management at Sheffield Hallam. He worked for Tata Steel, which was formerly British Steel or Chorus, for 13 years, including 5 years as technical manager of the Old Walk Steel plant in Rotherham. He is now a technical director of an iron and steel foundry in Chesterfield. He got his first telescope a few Februaries ago. We've not updated his bio. How many years now? Or how many telescopes? 8 or 9. Which was a 5-inch Newtonian, which he'd only had for 6 weeks before he upgraded it to a 10-inch, and now uses a 12-inch Newtonian to visually observe deep sky objects, as well as several smaller telescopes for astrophotography. His main interest is space flight and astrophotography, particularly globular clusters. So please, all put your hands up and welcome Andrew Kirton-Vaughan. Thank you, everybody.
Well, good evening, everyone, and welcome to my presentation tonight, where I will hopefully summarize some of the best and most interesting astronomical events and objects to observe during the autumn. Obviously, this talk's slightly out of sync because normally it would have been start of September or the end of August, but we're into autumn already. So a few of these events are not as in the past, but you'll get the gist as we go along. So. We go. So a brief summary of the sort of topics tonight. I'm going to talk about the moon and planets and what there's to see. Any comets and meteors that are around, which isn't really many. Interesting events coming up in the autumn. A little bit about asteroids and minor planets that you can see. And then because the dark skies are getting darker and nights are longer, I think it's a good chance to look at a few deep sky objects that are in prime position for observation in the next couple of months. So September, which is last day of today and is pretty much finished. There was a brief opportunity to try and observe Mercury a few days ago. Unfortunately, that's now passed. It is still one of the challenges I've set myself to try and observe, and there's a chance, I think, at the end of October to maybe do that. But it's a very challenging object, and I say one that I very much look forward to trying to have a go at it one day. Many of you will have noticed that Jupiter and Saturn have been nice and high in the sky around sunset, and hopefully you've taken the opportunity to get outside, especially if you've got a pair of decent binoculars, have a look up at Jupiter and observe the planet and the moons over many nights and see the progression as they orbit around. I think we'll cover more of this later on in terms of the planets that are visible throughout September. So just a brief look at where we are in the sky at the moment. Say Mercury and Venus, a bit of a challenge. Venus is just outside observation, and Mars is behind the sun at the moment, so too close to the sun for us to observe. When we get out into the outer planets, then as we can see at the moment, Jupiter and Saturn visible in the evening into the night, and Neptune and Uranus night and evening objects, and we'll cover those a little bit more detail after the summary of this section. As we move through into October, much of the same really. Jupiter becomes an earlier object, so if you want to observe that, you really need to get out as early as possible after sunset, and it's getting a little bit lower in the sky as well. And Uranus and Neptune are really coming into the prime position for observation as we go through into October and into November. and the times are getting a little bit earlier as well, so you don't need to stay up quite so late to get the best position in the sky throughout these months. Again, not really much viewing for the inner planets because they're all close to the sun or setting just to dusk. As we go into the outer solar system, as you say, Uranus is becoming more of an all-night object, and Jupiter and Saturn are moving into the early part of the night or into the evening as we go as we progress around the sun. As we get through into November, I think this is really the prime time where we can take the chance to observe the outer planets Uranus and Neptune, and I'll give a little bit more detail on what potentially we could try and different ways to observe the planets and ways what we might be able to see in a couple of slides time. I'll skip on to these. I seem to have misplaced the slide there. When we look at out at the planet Uranus, the next planet beyond Neptune, just suddenly realised that I can't actually see my notes, but Uranus, it will be visible for most of the night. As we move through into November, it will become visible a little bit earlier. It's going to reach opposition, so it'll be at its brightest on the 4th of November. And at the bottom of the screen, I've just put down a sort of indication of when Uranus will be at its highest. This is for yesterday, actually. So you can see at the moment the optimum time to view it's in the early hours of the morning, and as we move through into November, that optimum viewing period will move closer towards midnight, so it'll be a little bit more user-friendly to target. The image on the top right-hand side is taken from Voyager 2. And as you can see, Uranus is a relatively, even with a powerful spacecraft, it's still a relatively bland target. However, it does have some very interesting features that we can observe from the Earth. So these are a couple of shots. The top one is an amateur image taken with a C14 telescope from a gentleman in Texas. Unfortunately, much better skies than we would get in the UK, but he's been able to see the 5 largest moons of Uranus, which are Umbriel, Titania, Oberon, Ariel, and Miranda. The image at the bottom of the screen is taken with from the VLT in Chile, so a large diameter, multimeter professional telescope, and you can see there the larger moons of Uranus. I believe this is one of the targets that some of our members have had to go at in the past when they've been up at our observatory using our own C14 telescope, which unfortunately at the moment isn't in the best state for observation, but being able to capture the moons of Uranus, unfortunately, quite often the planet itself being significantly brighter than the moons often causes the, if you try to image it, often causes the planet to blow out and can obscure a clear picture of some of the moons. But it is a target that if you've got a largish aperture, Maxitov or Schmidt-Cassegrain telescope, that you can have a go at trying to observe. Obviously, if you observe optically, even with a very large telescope, amateur telescope, you're only really going to be able to pick out Uranus as perhaps a slight disk. I have observed it from our observatory, and I did manage to observe it as a disk rather than as a point of light like a star. That did require significant magnification in the order of 500 to 700 times. So you do need a large diameter telescope to really try and obtain that level of magnification, especially with our skies. You need optimum viewing conditions. This is an example using stellarium of the field of view that you could obtain if you had such the C14 telescope and a small webcam type astro imaging camera. Would be the red box that you would hopefully obtain. And you can see there that even with such a large magnification, the size of the planet Uranus and the moons is quite a small image, but it gives you a realistic field of view of what you might obtain. Obviously, if you're using a a smaller telescope and a DSLR type camera, you will get a significantly smaller image. But I think one that's worth, especially at the moment with a high position in the sky, if you know it's a prime position, it's nearly 50 degrees in altitude, it is an optimum time to try and image the planet Uranus at the moment, or even observe it optically. Obviously, the experience you'll get will be different depending on what technique you choose to use. We can also have a chance at the moment to see the outermost planet, Neptune. This is just past opposition on the early part of September, but it's still, for planet Uranus, still relatively bright. It's magnitude 7.7, so you will need a fairly large telescope to be able to pick it out amongst the background stars. So I suggest you don't need Newtonian, or ideally to get a decent magnification, Schmidt-Cassegrain or Maxwell-Cassegrain type telescope. Unlike Uranus, which has many large moons, Neptune only has one large moon, Triton, and that moon takes up nearly 100%, 99.5% of all the mass of moons in the Neptunian system. So that's the only one that we can really observe, and it is a very large moon. It has one of the highest ratios of size of the moon to size of the planet in the solar system, including the Earth. And the moon of Triton is actually still bigger than the planet Pluto. So if it was not associated with Neptune, it would actually be considered to be a dwarf planet in its own right. It's that big. This just gives you an idea of where the Neptune is in the sky. It's near the constellation Aquarius and Pisces. So relatively easy viewing. And this is, again, the field of view that you could obtain through Celestron C14 with a webcam type camera. As you can see, Triton is most likely to appear relatively large even compared to Neptune, because the planet itself, as I say, is quite faint. I just hope to have a couple of images elsewhere. So the bottom image on this slide is by Damien Peach, as we all know. Seems to be able to obtain rather good images of planets with the equipment he's got, but that is a non, you might deem, professional telescope image there. Obviously, if you've got smaller equipment with less magnification, then one of the opportunities you can take with these planets is to try and observe them over many nights. If you've got photography equipment, then even if you've got a lower amount of magnification, by being able to take images of the same field of view in the sky over a period of nights, especially with the planet Uranus, so hopefully you'll be able to pick out the planet by perhaps using like a blink comparator software, where you'll be able to flick between images and hopefully see what appears to be one star change position within the image over many nights. This is also the technique that was used in the past to discover planets, and it's one that with modern sort of computers and software, it's very easy for us to do, is to blink between multiple images and pick out the planet from the background stars. The human eye is very good at detecting change in images that appear to be relatively similar. So say if you've not got a big telescope, you've just got a camera and perhaps a 4-inch refractor or a Newtonian or something like that, you'd hopefully be able to pick out the planets from the background stars using a blink comparator type technique. So at the moment, we've got the opportunity to observe the International Space Station. You may even be able to go out tonight and observe it around 9:45 after the meeting, though it is very low in the west tonight, so not the best time to observe. But tomorrow, there's a very good pass at about 25 past 7. This information here I've taken from the website Heavens Above, which I find is one of the best and most up-to-date places and easy to get information about objects such as satellite passes. It can provide you information further into the future. They do recommend that you don't trust it past about 2 weeks, because the ISS can change its orbit, and therefore the tracks and the passes that's predicted are not accurate more than perhaps a week to 10 days in advance. So if you want to get more information further into the future, then I suggest you visit Heavens Above, or you can download an app on your phone, Heavens Above app. The International Space Station is there. Another website I would recommend people look at is one called Transit Finder, and that will also show you whether there's any passes of the ISS over the sun or the moon close to a location that you reside at, or how far away you would need to travel in order to see such an event. I also think it's one that if you get the chance and you've got some time, then it would be good to try and capture such an event. Though it's a bit of a challenge, and I've talked about that in a couple of previous talks such as this about techniques for capturing transits of the ISS across the moon or the sun. But the ISS obviously visually observable from the ground or with a low power pair of binoculars. If you know where to look, it should be relatively easy to pick out, given it's extremely bright. Tomorrow night's passes at magnitude -3, so it should be very easy to pick it out against the background stars once you know which direction to look in. There is a partial lunar eclipse coming up in the not too distant future. It's on the 19th of November, though unfortunately we are not in the best position to actually observe it. You need to be in Australia or Oceania, around that way, part of the world, to really get the best view. We will get a minor penumbral lunar eclipse just after sunrise in the morning. The peak part of the eclipse actually happens below the horizon, but we will wake to a partially red moon in the west as the sun rises in the east. So we've got a clear view to the west on 19th of November. You'll be able to see right down to the horizon with no real obstruction, and hopefully you might be able to observe a red half-blood moon on the morning of Friday, November 19th. So again, if you're going out to work, that might be one that's easy to potentially stop for a few minutes and take a look at and observe. Couple of objects that not really covered before, but I think are in good position at the moment for observation, though perhaps like Uranus and Neptune could be a bit of a challenge, depending on what equipment you've got access to, would be to observe some of the objects in the asteroid belt. So one Ceres is the largest asteroid that we know about in the asteroid belt. As the asteroid belt, everyone sort of sees it on images and thinks it's some sort of continuous belt of small rocky objects between Mars and Jupiter, but in reality it's a very, very spaced out, low density collection of relatively small objects. And as we can see here, Ceres itself, one object, accounts for about 25% of the total mass of the asteroid belt. It's still relatively small. It's only nearly just under 500 kilometers in radius, and still it's a total volume about 14 times smaller than the dwarf planet Pluto. But as far as the asteroid belt is concerned, it's a very large object. And it reaches opposition on the 27th of November, so just towards the end of autumn. It's going to be very high in the southern sky. It's going to be quite close, actually, to the position of Uranus. And it will be of a similar brightness, actually. Uranus will be at around magnitude 6.7, and Ceres will be about 7.1. Because Ceres is significantly closer to the Earth than Uranus, as we travel past it, it will appear to travel across the sky much faster. So this is a prediction of the position of Ceres over the next month or so, and it's in the constellation of Taurus, and it's going to just come out of a sort of retrograde motion as we go inside it on our orbit, and then it's going to start traveling towards the west over the next few months. So the current position be on the left there. And then towards the start of November, it's going to pass right under the bright star Aldebaran in Taurus, and then continue across the sky up towards the Pleiades. And I'm sure it will pass very close to those probably in the early part of next year. So again, it's relatively low brightness, only magnitude 7, just over magnitude 7. And therefore, I think one of the best techniques to perhaps pick out Ceres again is to take multiple shots or photographs of this area of sky over many nights. You don't need to do it every night because it's not going to travel that fast, but maybe once a week for a period of time, and hopefully you'll be able to pick it out against the background stars, again using some free available blink type comparator software. So that's the Ceres brightest minor dwarf planet, sorry. One of the other largest objects in the asteroid belt is 2 PALLAS. These are numbered in the order they were discovered in. Though PALLAS isn't actually the second largest object in the asteroid belt, it's just the second one that was discovered. Unlike most of the objects, it's actually in quite a heavily inclined orbit to the ecliptic. So it's just past opposition about 3 weeks ago, but it's smaller, significantly smaller, and therefore significantly fainter than Ceres. The image that you saw on the screen of Ceres was taken from the Dawn probe, which passed close to Ceres in 2016. Because Pallas doesn't lie on the ecliptic, it's extremely difficult to try and aim any form of spacecraft at it, because there's no way to do any gravitational slingshots in order to fire the spacecraft easily out of the plane of the ecliptic. And therefore, this shot is actually taken from the VLT telescope in Chile. The image on the right shows you the position of the planet. It's currently in the constellation of Pisces, and it's visible for most of the night. It's a bit fainter again, and I think depending on your pointing abilities with the telescope, again, it might be easiest to try and pick it up by taking multiple images over multiple nights, looking for a star that effectively change the position in the sky. And the final one I'm going to talk about is Eris, not to be confused, as I did earlier, with Eris. Eris is a dwarf planet out towards the Kuiper belt. Eris is an asteroid in the asteroid belt. It's one of the sort of largest 4 objects in the asteroid belt. There's also Vestas, and between Eris, Vestas, Pallas, and Ceres, they make up about I think it's about 50 to 60% of the mass of the asteroid belt is taken up in these 4 objects. So you can imagine the rest of it's relatively small. It's currently in Gemini. It's significantly fainter than at the moment than the other objects, though towards winter time, November through March, it will become brighter. So in January, mid-January, it's at opposition, and its magnitude will be comparable to Neptune, around magnitude 7.5 to 8, depending on exactly how close it comes and how the surface is reflective. Again, the image in the center at the bottom is taken from the VLT in Chile. As you can see, it's very high in the sky again. Towards November time, it's up towards sort of 55, 60 degrees altitude when it peaks. So should be relatively easy to find a clear view of the sky in that position, southern sky, from where you are, hopefully. This is a diagram showing the position of Eris across the next couple of months. So we'll look at a couple of deep sky objects now. I'm just going to see if I can actually bring up my notes on the screen, because at the moment I can't see my my notes. There we are. Are you seeing what I'm seeing, Paul? Are you seeing my notes as well? Unfortunately, can't hear you, Paul, because you're muted.
No, we're not seeing them.
Are you just seeing the presentation?
Thank you, Andy. We're just seeing the presentation.
That's fine. Well, I can see my notes now, so that's good.
Okay. Carry on.
I'll carry on then.
Thank you.
So we're going to look at some deep sky objects that are good viewing for the next couple of months. I've got a mixture of mostly relatively easy beginner friendly ones, though I've got a couple of fainter ones for those that want a bit more of a challenge. So we are, this is a map of the sky showing all the MESSIER objects. There are different symbols depending on the type of object, for open clusters, globular clusters, nebulae, etc., etc. And the part of the sky that we are going to be looking at is probably about 10% on the left of the screen and about 10% on the right of the screen, because unfortunately that's just the way the picture's been, the diagram's been rolled out across the page. So we're looking at constellations around Pegasus, Aquarius on the left, and across into Andromeda, Pisces, and Cassiopeia on the right hand side of the screen. And you can see it's a mixture of galaxies, globular clusters, and open clusters to be within those constellations. And these are the constellations that are the best viewing for the next couple of months. As we move through into winter, we'll move across the screen to the left and we'll get into constellations like Taurus, Orion, etc. But those are Gemini, those are more the, as we tend to be, the winter constellations. So the first constellation I want to take a brief view of is the constellation of LYRA, which is one of the smallest constellations, though it has got a couple of very interesting objects in it. So this is a sort of annotated star map of LYRA. There are only two MESSIER objects in LYRA, and perhaps the most famous one that everyone knows is MESSIER 57, which is the Ring Nebula, which we'll show a little bit in a minute. There's also a globular cluster, M56. LYRA is generally relatively easy to find because it contains the extremely bright star Vega, which is relatively close to us. It's only 25 light years away. So that's, as far as most stars go, quite close. And it's the second brightest star in the northern hemisphere. So once you know roughly which direction to look in, it should be very easy to pick out the constellation of LYRA. And just below Vega, you see the sort of parallelogram shape of the main part of the constellation. So MESSIER 57 is relatively easy to find with a optical observation. We'll show a couple of images in a minute. So this is a sort of stellarium shot of MESSIER 56, which is a globular cluster. It was discovered in the 1770s by MESSIER. Not all MESSIER objects were discovered by MESSIER. So one of the smallish but relatively bright globular clusters. So this is a typical view you'd get with a I think about 4-inch refracting telescope with a sort of medium powered eyepiece. So it's a relatively small object optically. But my favorite way to observe globular clusters is to image them. It's really the best way to try and get an idea of the density of the cluster, the way that the stars are arranged. So are they highly concentrated towards the center? Are they quite diffuse? What sort of colors of stars are in there? Which also gives us an indication of types of stars. And this is an amateur image, not one of mine, unfortunately, an amateur image of MESSIER 56. So you can detect it with binoculars, 50 to 80 binoculars. Hopefully you'll be able to pick it as a fuzzy object in the sky. And obviously Messier originally was looking for comets, and as such, with his poorer optics they had back 200 years ago, it appeared to be a comet-like object in the sky, a fuzzy blob. Obviously with today's equipment, even with small telescopes, but with photographic equipment, we can determine it's not a comet, it's a collection of relatively densely packed stars. So I think globular clusters are good objects to have a go at. They're quite bright, so if you're say new to astroimaging, for example, they're good objects to start at. They're relatively easy to find, they're quite bright, you don't need to spend 8 or 9 hours trying to image them. 20 minutes, 40 minutes, an hour is by far plenty time to collect sufficient data in order to achieve a good quality image. So one, I'd say a set of targets I would strongly recommend if you're getting into astrophotography at all. Obviously, if you're a visual observer, it's a good challenge to try and set yourself, see how many you can observe in one night. When we move on to the Ring Nebula, obviously the Ring Nebula is a planetary nebula, so it's the remnant of an exploded star that went supernova. It's relatively easy to find because it sits on the path between roughly 50% of the way between two bright stars in the constellation of LYRA. So that's Sulfat and Sheliak. These are the two bright stars, and the Ring Nebula sits roughly halfway between the two in the sky. Observed optically, which I've done many times. Again, typically need some pretty decent magnification, so some form of a Cassegrain telescope. The Ring Nebula appears like a smoke ring, really. Very monochromatic, but clearly a ring-shaped object. So it's quite observable visually, but you do really need a decent amount of magnification to see it. However, it is one that I have imaged several times, and this is my own image I took several years ago from our observatory up at Hoover with the C14 telescope. And you can see clearly there that you've got some lovely colours. The outer ring, the orange and the yellow, is the original outer part of the star that was ejected just before the star went supernova. And then when the supernova occurred, it sent out a huge shock wave into space, and that shock wave caught up with all the slow traveling hydrogen and helium that had been ejected earlier, and effectively caught up with it and shoved it forwards, and that's created effectively a vacuum of hydrogen and helium behind the shock wave. Hence the orange and the yellow colours are outside the shock wave, and inside that you tend to get the greens and blue colours of the elements like oxygen that were left inside the star when it went supernova. So it's a very interesting object to observe both visually and photographically. But you do need to get a good photograph, you do need a larger telescope and quite a lot of time because it's relatively faint. As we move over into Sagittarius, then we've got the asterism, the teapot, which you should be able to make out when trying to find the constellation. And when we look at a map of the constellation, which is a large constellation, there are a significant number of MESSIER objects within Sagittarius, quite a significant number of globular clusters and open clusters, and there are a couple of planetary nebulas as well. So we'll go through a few of those. So this is M75, which is a globular cluster. Again, these tend to find that the higher MESSIER number globular clusters are quite small. So the famous ones that we know about, M3, M5, M15, M13, also these were larger and found much earlier by MESSIER, hence the lower number in his catalogue. When we get up to the 50s, 60s, 70s and so on, then they tend to be smaller and fainter, and more of a challenge to find visually. Again, another amateur image of MESSIER 75. It's also known as NGC 6864. These objects are generally all about the same distance away from the Earth, because they migrate. Globular clusters tend to sit mostly in a cloud around the Milky Way, almost as not really dwarf galaxies, but they are, collections of tens or hundreds of thousands of stars they're sort of orbiting our galaxy as our galaxy moves around within the universe. So that's the only one I'm really going to focus on in Sagittarius. As we move over into Pegasus, obviously Pegasus is famous for the great square of Pegasus, which is an easy way to try and pick out and identify the constellation, because the main part of it forms this very defined square in the sky. Now, Pegasus itself doesn't have very many MESSIER objects in it. It's just one, really, which is, as I mentioned earlier, is one of the low MESSIER number globular clusters, MESSIER 15, and it is one of the larger, maybe half dozen globular clusters in the MESSIER catalogue. So it's bigger and brighter than the couple of globular clusters we talked about earlier. Still significantly distanced from the Earth. It's about 40,000 light years away, and it contains over 100,000 stars, including variable stars, pulsars, neutron stars. Even does contain probably several planetary nebula, because there will be stars in there that have gone supernova over time. But obviously, from the Earth, with the equipment that we've got access to, we're not going to be able to see planetary nebulas several tens of thousands of light years away. They're just too small and too faint, and in many cases, in this case, blocked out by the light from all the other stars in the cluster. So, looking at MESSIER 15, this is actually one of my own images. One of the earliest images I took. I was photographing globular clusters, and I've never actually gone back to it. So this was taken with the again C14 telescope at our Hoover Observatory, with a DSLR type camera. And it's only about 30 minutes worth of exposures. One of the tricks with imaging globular clusters is to try and get the right color balance, so you end up with a good color of stars. Otherwise, you can easily end up with green stars or purple stars, or various other many shades of stars. But if you can get your processing right, then you should hopefully be able to get back to sort of a mixture of white, blue, and orange stars, which gives you an indication that you've got a relatively accurate representation of the true color of the stars. A good object to try and observe with binoculars. It's significantly brighter than some of the smaller clusters, and relatively easy to find within the constellation. There's some good pointer stars in order to direct you towards it. Into the constellation of Capricornus, just nice and high in the sky. We've just got another globular cluster, MESSIER 30 in Capricornus. So it's again a bit fainter, but than M15. all these objects were discovered in the typically around sort of 1760s through to 1780 by Messier. Also, some of the very later objects in the catalogue, up towards 100 or so, were often discovered by other people and added to his catalogue later on. This is a typical amateur image of Messier 30, not one of my own, unfortunately. But as you see, it's significantly smaller and less dense than the Messier 15. Again, I think with globular clusters, it's a good, if you've got clear skies and decent pair of binoculars, it's a good idea to have a look at a star map, make a list of objects that you can hopefully see, and then maybe take 10-15 minutes to observe each one and then move around the sky. So over a period of an hour or so, you can hopefully observe half a dozen or so objects relatively successfully. Over into Cassiopeia, constellation that I've photographed quite a bit, perhaps more so wide field. I find it's a nice image to, I've not got too much time to put my camera on a sort of star tracker mount with a wide angle lens, maybe something about 50 or 100 millimeters, and take some nice wide angle shots of Cassiopeia. It's not too big, but has got some interesting objects in it, and then I like to see if I can pick those out in the wide field shots. It makes the characteristic W shape in the sky, and it's very, very easy to pick out in the autumn and winter sky. It's nice and high, especially this time of year. So in Cassiopeia, we've got a selection of open clusters and to look at, and also some get smaller galaxies towards the bottom, though they are those are not Messier objects, these are NGC objects, so they tend to be too much smaller. So this is an open cluster. It's Messier 52, which is just sort of highlighted in the center of the screen by the blue corners of the box. I'm not a big observing fan of open clusters myself, apart from perhaps the Pleiades, but I have observed Messier 52 when I actually focus on another object in the sky, which is the sort of red blob that you can see on the screen just to the above Messier 52, and this is image of that object that I've one of my own images that I took a few years ago, and you can see Messier 52 to the left of the screen, and then to the right is an object called the Bubble Nebula. As you can probably tell by it, it's a region of hydrogen gas that appears to have a bubble born in the middle of it, and that bubble is the result of an exploding star supernova event that took place within the interstellar hydrogen matter, and the shockwave from that supernova has again progressed outwards and compressed the interstellar hydrogen ahead of the shockwave and created this bubble feature within the interstellar gas. So it's an interesting. It was quite a challenge to image and get a nice picture of. But you can see to the left, the cluster itself is not that dense. I always sometimes wonder what sort of images Messier was getting through his equipment to see some of these open clusters as fuzzy possible comet type objects, because even with the sort of equipment we've got today, even more basic telescopes, 3-inch, 4-inch refractors, it's very easy to determine that these objects are collections of stars, and some of them are actually very, very diffuse, not very dense. So what Messier was seeing, I'm very interested to know what he actually saw, what he thought what they were. This is another open cluster, Messier 103. A bit more interesting perhaps than Messier 52, because you've got a couple of very, very bright stars, which are some of which are actually not associated with the cluster. They're in the foreground, and the cluster of stars is actually behind it in terms of space. It appears to be in line of sight as far as we're concerned. Over into Andromeda, perhaps one of the obviously most widely observed MESSIER objects in the sky. Andromeda itself as a constellation is not one that I've ever really focused on, more apart from perhaps say looking at MESSIER 31, the Andromeda galaxy, hence it's being positioned in Andromeda. So M31, the Andromeda galaxy, is also our closest neighbor galaxy, and it's part of the collection of 3 galaxies that are known as, to us as the local group, MESSIER 31, ourself, and also MESSIER 33 that we'll look at shortly. Relatively easy to find. You find the star Mirach, and then follow a number of pointer stars up to the northwest, directly towards MESSIER 31. If you've got a reasonable unlight polluted sky, unfortunately probably perhaps not in the South Yorkshire metropolitan district, but I've out towards places like Lincolnshire, it's quite easy to see MESSIER 31 with the naked eye in the sky as a sort of fuzzy blob. If you're in a more populated area with a bit more light pollution, like around Rotherham, Sheffield, Barnsley, Doncaster, then you really need a pair of small binoculars to really pick it out clearly from the background. So 10x30s or 10x50, something like that. I'd say the bigger aperture, the better to get more light in. But it's easily observable as a fuzzy object in the sky, and very, very large. It's about 4 times the diameter of the full moon. So though it appears very, very diffuse to us, because it's the stars in the galaxy are so spread out, it is a huge object, and as a result quite a challenge to image. So this is the stellarium shot of the Andromeda galaxy, and so this is it's an extremely good amateur image of the Andromeda galaxy. I should actually put one of my own in. I don't know why I didn't, but one of the challenges of photographing Andromeda is really trying to get it all in the frame of view. The first time I ever had to go imaging it, I had an 80mm refractor with a focal length of about 650mm and a DSLR camera, and even orientating the galaxy across the diagonal of the frame, I probably only got 60 or 70% of it in the field of view. It is that big an object, and yes, it's a couple of 100,000 light years away from us, but it is, relatively speaking, very, very close and very, very large. Obviously, it has satellite galaxies, MESSIER 32, which you can see just below the main galaxy, and MESSIER 110, which is just up and slightly to the left of the main galaxy. It's one to very definitely binocular observe, and if you're wanting to try and image a galaxy, it's one to have a go at. So you don't need big telescope. If anything, the smaller the telescope, the better for this one, in order to get it on the field of view. Our other closest neighbor galaxy is in the constellation of Triangulum, so called because it makes a triangle shape in the sky. It's perhaps one of the smallest constellations in the sky that's still recognized, but it does contain the Triangulum galaxy. This is a stellarium image. Is significantly smaller than M31, but still quite large in the sky. And here is a say, an amateur image of it. I tried to image it once, but I think I got clouded out in the time I tried to do it, so I've not really got enough data to produce a decent image myself. It's significantly fainter than MESSIER 31. You could probably get a good image of M31 in a couple of hours. If it's dark enough. MESSIER 33, I think you need probably at least 4 hours of imaging to get enough data to get a decent image out of it. It's significantly fainter. And it's a bit more face-on than Andromeda, and as such, it appears a bit more diffuse. Again, I have observed it with binoculars. If you need a little bit of darkness, a bit of a challenge from within a populated area, but if you can get out into the countryside a few miles and get away from a bit of significant light pollution, and I should be able to observe that with binoculars without too much problem. We'll just jump into Pisces briefly, which is next to between Pegasus and Triangulum, and we've got another galaxy with a good structure, which is M74. Appears to us as a face-on spiral, so we get a good potential to pick out the structure in the galaxy, but it's quite faint, and a bit of a challenge. I've never seen this one with binoculars myself, though I suspect it's potentially observable. We've got maybe got some ATV binoculars in a dark sky site. I don't know why that one's in again, because we've covered it. Last but not least is the Little Dumbbell Nebula, which is just get back. Sorry, MESSIER 76. It's a planetary nebula. So again, observation-wise, with a larger telescope, you'll pick out a bit of structure, a bit of shape, but mostly be monochromatic. If you've got the access to camera equipment, then hopefully you'll be able to pick out an image such as this with enough patience. You can see all planetary, although you'd expect perhaps a lot of planetary nebula to look a bit like M57, the Ring Nebula. Almost every planetary nebula I've seen is different, and that's perhaps why they're so interesting to try and observe, because each one is different, has different structure, and obviously resulted in a very different set of conditions within the star just before it went supernova. So after doing globular clusters, perhaps my second favorite object to try and observe is planetary nebula. Unfortunately, to do it well, you really need a really large telescope with a lot of magnification to get an image that really shows any significant structure. So 11-inch or 14-inch type Cassegrain scope is really optimum for trying to image these sort of objects. And that is the end of my presentation for tonight.
Andrew, thank you once again. The amount of information that you give us, more objects there than you can shake a stick at, and definitely not enough clear nights to do it all justice. Could I ask you to stop sharing your screen? So I am looking for digital hands, please. Otherwise, I do have a couple of screens to look at tonight. So wave at me frantically if you can't find out how to put up a digital hand. So questions? Nobody. Oh, all right. So we've got Trev Worrell.
Good evening. I just
evening,
wondered.
Trevor.
Hiya. I just wondered if there's any comets due to make an appearance.
Not until perhaps January time. I did have a look. There's not at the moment, everything's sort of magnitude 10 plus. There is predicted to be one. I can't remember what, I think it's C 2021A1 perhaps, which might reach magnitude 5 in January, but it's still down at sort of magnitude 10, 11 at the moment. I can't remember the name of it, but if you obviously use the comments of the Northern Hemisphere website, it gives you a prediction on what we might get. Obviously, it's still 3 or 4 months away, but the prediction is it might hit magnitude 5.
Yeah, I think that's the Japanese site you're talking about.
Yeah, it is. Yeah,
visible comets in the Northern Hemisphere.
Yeah.
Thank you for that.
Okay.
Thank you.
Thank you, Trevor. Ian Hargreaves. Unmute yourself, Ian.
Sorry about that.
Okay. Yeah. Good evening, Ian. Can we have your question, please?
Yes. Sorry about that, Paul. One of the objects in LYRA that wasn't mentioned, which I tend to like just looking at every now and again, just to see how good my telescope is the double.
Yes.
Is it Epsilon LYRA?
Yes, Epsilon LYRA.
Yeah. That's always fascinated me, and it is a good test of a telescope as well, isn't it? If you can see the two doubles and the way that they lie at right angles to each other, the two doubles. But I just thought I'd mention it.
The other one actually I've missed out, and it's is the double cluster. Again, it's probably, I think it was the first object I actually ever imaged myself, because again it's very bright. I think I only did about 75 minutes of imaging on that night, and I've got a really stunning image of that. So and it's again quite nice to observe visually, because you got the two open clusters effectively nicely spaced out, and it's always at this time of year very, very high in the sky. So not the easiest thing in the world to observe with binoculars, because it tends to give you a bit of a crick in the neck, but it's again a great one to do a bit of if you've not got a lot of time, it's a nice one to do a bit of photography on.
Really great shots of those globular clusters. I enjoyed those.
Thank you, Ian. Steve Taylor.
Hello, Andy. What I wanted to ask you was about International Space Station. I've noticed probably for the last, it will be for probably 2 weeks, I think every night it has been visible.
Yeah, you get, there's often 2 to 3 week periods where it's visible every night, or if not multiple times through the night, and then it can be not visible again for another 4, 5, 6, 8 weeks sometimes.
Yes, I just wondered if there was any reason, if they altered anything on the space station.
I haven't looked into it, and I don't think so. But when I've presented these presentations in the past, I've noticed in 2 to 3 week blocks, and then you can be 4 to 6 weeks without any observations. And I think it's obviously passing over us, but it's passing over us a lot during the day, if you think, because it's in a 90-minute polar orbit, isn't it? So
I think it is to do with the orbit precessing around the Earth, and so a lot of the passes appear during either the early morning, and so it's a south pass, which is difficult to spot, or it's during the day. So it's just a case of it's celestial mechanics basically, and the way the orbit.
Yes, I just wondered if it altered that height of the orbit or anything.
No, it's got to do with the fact that the orbit is slightly inclined.
Yes.
To the equator, and that orbit processes around as well, because it's an 80-minute orbit, so it doesn't coincide. Yeah. Okay, I'm still looking for questions.
We've got one from Ash Higgins, I think.
Ash Higgs from Mid-Kent. Ash, welcome.
Thank you. An interesting talk, Andrew. Thank you very much. Earlier on, you mentioned Transit Finder. I used to use CalSky, but that's gone off the air now. I've just tried putting Transit Finder in as an app, and I can't find it. Am I missing something?
Not an app, it's a website.
Okay, that solves it. Thanks very much.
Okay. And any more questions?
Proxy moron.
Oh. Mike Boxon. Yes, it's
yeah, this is just a little polite correction. Planetary nebulae have got nothing at all to do with supernovae.
say again, Mike.
Mike,
Say all again.
Okay, just a polite correction. Planetary nebulae have got nothing at all to do with supernovae. Supernovae are caused by very, very massive stars, whereas planetary nebulae are basically very old stars. In about 10 billion years' time, the sun will be a planetary nebula, because planetary nebulae are what happens when sort of mid-mass stars like the sun age, and they throw off their outer layers, which is where you get different colours from, because of the different nuclear reactions that are going on in the centre of the star. You get different elements produced in the outer layers, and that's where you get your different colours in the planetary nebulae. But they've got nothing to do with supernovae.
Okay. Thank you for bringing that to our attention, Michael.
Cheers.
Back to the books for all of us. And I'm looking for one more question. And is it a statement or a question, Phil?
Oh, both.
No, it can't be both. It's got to be one or the other.
A statement. MESSIER, I think nearly half of his album was known with the globular clusters and fuzzy nebulas before he wrote his MESSIER album. But it was at a period, 1700s, when everybody were comet hunting, and I think people kept writing in and claiming they found these brand new comets when there were already objects in the sky that people like MESSIER knew about. So I think he kind of wrote the MESSIER album and published it so people could look through the album and say, oh, this object in this location is not going to be a comet. And I think it stopped a lot of people trying to claim they'd found stuff when they really hadn't, and they were just fixed objects in the sky. And I don't know why M45 ended up as a MESSIER object, because it's clearly not a comet or even cometary-like. But I think MESSIER discovered a lot of the MESSIER objects once you get into the late 40s and 50s and on upwards. I think some of them are even a bit spurious. But yeah, it's an interesting catalogue. But yeah, a lot of it was designed to tell people, look, this into comet.
Oh, it very much was
yeah.
It's a list of non-cometary objects.
Yeah.
And how people.
Have you got the book? Have you got the book, Andrew?
How some of the very diffuse open clusters could be categorized as objects. As you said, I think Pete's pointed out, he probably was using around a 2.5 inch refractor, but obviously without knowing the quality of the optics, it's difficult to get an impression of. Well, have to go out and buy one of these £3 Chinese plastic eyepieces and shove it in a telescope and get an idea of what you might have saw.
Yeah. Well, I've got myself a 200-year-old 40mm brass telescope, and quite often when I look at objects, I have a look through this little old telescope I've got as well, just so I can get some idea of what they were looking at. And if you look at Hercules M13, it definitely looks just like a comet. It looks just like one of them classic comets through a little refracting telescope. And I think that's fascinating, because you can see we know what it is, and you can see it through a modern telescope. And then I can look at this and think, I can see why they thought it might be unusual. just an observation.
Did anybody see the display from the Landsat 9 launch on Monday night?
Good images on the BBC.
Rocket
taking amateur shots of the sky, but not myself.
Right. Just Robinson wants to know. for those people who missed it, the rocket did a maneuver and basically left a large cloud that was caught in the sunlight, high up sunlight. Once again,
it was on the news.
It was on the news. The second part of Jess's question: how was it possible we could see it in the UK when it was launched from California? I think the Landsat satellites have got a higher inclination to the equator in their orbit than the ISS, so they actually pass over the north of Scotland rather than the south coast, and so yeah, they cover a lot more of the Earth's surface.
Well, can I just tell you something, Paul? While on about satellites, the other week when they launched the SpaceX, I didn't know what time it was launched, but I just happened to be putting the rubbish out at 12:15 on the night when it was launched, and just as I was walking back in the house and I shut the bin, I looked up and I could see this thing drifting across the sky. Thought, that's a bit of an unusual orbit. It's a bit like International Space Station, but it's higher. Anyway, I thought, don't know what that is. It's a bit unusual. Anyway, I went to the house. Anyway, the following morning, I saw on the Facebook page that popped up that they'd launched it, and I thought, I wonder if we could have seen it. Anyway, I went to Heavens Above, and it put the orbit on. And when I looked at it, it had flown over the UK, and it was higher than the space station, as in latitude in the sky. And when you look at the actual altitude, it's about 50 kilometers higher. I don't know if it was at 51.5 degrees, as in the inclination to the equator, or it was something similar to that and higher in the sky. And I reckon I saw it, and it was probably 15-20 minutes after launch from Florida.
Right.
So whatever launches in America, it doesn't take long to fly over the UK.
No. Well, presumably that was before they broke the space toilet. So if nobody has any further questions for Andrew, Andrew, once again, thank you for the update. You've given me lots of things to think about having looked at. Ladies and gentlemen, can we give a big Mexper and Swinton thank you to Andrew Kirton-Vaughan? Thank you, Andrew.